Welcome. Today, we are diving into one of the most incredible pieces of engineering you will ever encounter. And guess what? It's already inside your body. We're talking about the kidney, your personal, always-on purification system. To really appreciate what your kidneys do for you, let's start with a simple, kind of unsettling question. Just imagine for a second, what if your body just stopped cleaning up after itself? What would actually happen? Well, here's the problem. Just the act of staying alive creates waste. Every single process, from using the energy in your food to building new cells, it all generates byproducts. And some of these, like ammonia, are seriously toxic. If that stuff builds up, it's pretty much game over. So every living thing has to have a way to get rid of it. And as it turns out, over millions of years, evolution came up with three really distinct ways to solve this universal trash problem, and each one is perfectly tailored to a different environment. Let's take a look. Okay, so what this table shows us is this really fascinating trade-off that nature has to deal with. See, if you live in water, like a fish, you've got it easy. You can just dump highly toxic ammonia right into your surroundings, no big deal. But on land, you absolutely cannot afford to lose that much water. So mammals, like us, we spend a little energy to convert that toxic ammonia into something less harmful, urea. It saves a ton of water. And then you have birds and reptiles who take it even one step further. They create uric acid, which is basically a paste and requires almost no water at all to get rid of. Pretty clever, right? And that brings us right back to our solution, the human kidney. And I want to be clear, this is not just some simple filter. It's an unbelievably sophisticated purification plant that handles all that urea for us with incredible efficiency. And the scale of this whole operation, it's just staggering. Each one of your kidneys is packed with about 1 million tiny individual filtering units. These are called nephrons, and they are the absolute workhorses of the entire system. So it's super important to get this. Everything the kidney does, filtering out the bad stuff, balancing your body's salts, managing your water levels, it all happens right here, inside these microscopic nephrons. This is where the magic happens. This is where dirty blood goes in and clean blood comes out. So how does it actually work? Well, to really understand it, we're going to follow a tiny drop of your blood on its journey through just one of these million nephrons. It's a 3-step purification process. Okay, first, you've got this massive initial dump called glomerular filtration. Basically, high pressure just forces a ton of fluid and small stuff out of the blood. Then, second, you have an incredibly picky process called tubular reabsorption, which pulls back everything your body actually wants to keep. And finally, there's tubular secretion, which is kind of like a last-minute cleanup crew, actively pushing a few more waste products into the fluid just before it becomes urine. And to give you a sense of the just raw power of that first filtration step, get a load of this number. Every single day, your kidneys produce 180 liters of filtrate from your blood. That's enough to fill a whole bathtub every day. Which of course brings up a very obvious question, right? If we're filtering that much fluid, why aren't we just constantly looking for a bathroom? The answer is all in that amazing second step, reabsorption. And here it is. This is the key to our survival on land. Your body reclaims an absolutely incredible 99% of that initial 180-liter filtrate. Think about that. All the hard work of filtering is followed by the even harder work of taking back exactly what's needed. And this isn't just a passive thing. The nephron is actively, intelligently pulling back all the vital stuff. Glucose for energy, amino acids for building proteins, electrolytes like sodium, and of course, a massive, massive amount of water. It's a smart system that knows exactly what to keep and what to let go of. But how does the kidney manage to concentrate all that leftover waste into just the 1 or 2 liters of urine we actually produce? Well, to do this, it uses an absolutely ingenious biological trick, a true masterpiece of evolution called the countercurrent mechanism. The whole secret is to create this really intense saltiness gradient deep inside the kidney. The outer part, the cortex, is about as salty as your regular blood, but as you go deeper and deeper into the inner medulla, it gets 4 times saltier. This gradient, this is the key to everything. So why build this gradient? Well, the kidney basically builds a salty sponge in its core, using salt and even some of that urea we're trying to get rid of. So as the final filtrate passes through this super salty area,
water just gets pulled out naturally by osmosis, leaving behind highly concentrated urine. It's how we get rid of waste with the least amount of water loss possible.
Now, a system this complex and this vital can't just be left on autopilot. It needs to be constantly adjusted based on what your body is doing. Like, are you dehydrated? Is your blood pressure too high? This constant fine-tuning is handled by hormones. And this isn't just one signal. Think of it more like a constant conversation happening between your brain, your heart, and even cells inside the kidney itself. They're all working together in this beautiful feedback loop to maintain perfect balance, or what scientists call homeostasis. Let's look at the most famous of these systems. Okay, let's just walk through this. So let's say your blood pressure drops. Special cells in the kidneys sense this and release an enzyme called renin. Think of renin as the starting gun. It kicks off a chain reaction that ultimately produces the real powerhouse here, a hormone called angiotensin II. Now, this hormone does two critical things at once. First, it physically squeezes your blood vessels. That's called vasoconstriction, which instantly raises your blood pressure. And second, it sends a signal to another hormone, aldosterone, telling the kidneys to pull more salt and water back into the blood. More fluid in the pipes means higher pressure. It's a perfect, self-correcting loop.
And it's not the only system in town. If you're dehydrated, for example, your brain releases ADH, which tells the kidneys to save more water. But on the flip side, if your blood pressure gets too high, your heart actually releases a hormone called ANF that does the exact opposite. It works against that renin system, causing your blood vessels to relax. That's vasodilation, which brings your blood pressure back down. It is this constant, delicate, hormonal push and pull that keeps everything perfectly in balance. So when you really put it all together, it's so clear that the kidney isn't just a filter. It's a regulator, it's a balancer, and it's a silent guardian of your body's entire internal world. It performs a job so complex and with such amazing efficiency that our best technology, things like dialysis machines, can really only offer a crude imitation. This incredible biological machine works around the clock, 24/7, without a single day off, for your entire life. So the final thought here, the big takeaway from all this complexity, is actually a pretty simple question. Knowing how unbelievably hard your kidneys work for you, what can you do to help them out? Now that is something worth thinking about.